Hello everyone, welcome to the session of class 9 mathematics, and I'm your Anu again for mathschool.1. Today it's a continuation of some inequality relations in triangle. We have already seen some, and let's continue with this. Okay, so today's problem is if AD is a bisector of A. So A is angle A and AD is the bisector. So bisector is a line which divides the angle into two equal halves. So 1 is equal to 2 because AD is the bisector of A. Show that AB, see AB is greater than BD and AC greater than CD. So it is enough if we just prove this part because it will be the same thing. We'll be repeating the same thing for the next part. Okay. So first thing, AB greater than BD. AB greater than BD. See, if AB has to be greater than BD, let's take, since angles are known to us, one of the condition is we have a bisector here and we have two angles to be equal. So let us take it from the angle point of view and we'll prove the sides. Okay. So now since AD is the bisector, we have angle 1 is equal to angle 2. So that is given because AD is a bisector and it divides angle into two equal halves, isn't it? So now, let's see, let's consider AB, we need to prove AB greater than BD, isn't it? So let us consider the triangle ABD. See, triangle ABD. Okay, so now it's the triangle ABD and you can refer to this triangle too for solving this, for proving this. So take the triangle ACD. In triangle ACD, see, in triangle ACD, this angle 3 inside this triangle ABD, and for this triangle it is exterior part. For this triangle, angle 3 is the interior angle, but for this triangle ACD, angle 3 is exterior angle of D, right? So exterior angle D, what do we know about the exterior angle? Exterior angle is always the sum of opposite interior angles, right? So angle 3 will be equal to angle 2 plus angle C, right? So exterior angle 3, exterior angle D is equal to, it is given by angle 3, which is equal to angle 2 plus angle C according to this triangle, right? So what does it mean? It means that angle 3 is equal to sum of these two angles, angle 2 plus angle C. So it has to be definitely greater than either of the angles, right? So angle 3 is greater than either 2 or C, isn't it? It is greater than both the angles. So I can write it as angle 3 is greater than angle 2. Is it right? Yes. So angle 3 is greater than angle 2, isn't it? So now we have 1 is equal to 2. It is already given. So since 1 is equal to 2, I can replace this angle 2 by angle 1. So which implies angle 3 is greater than angle 1, right? Angle 3 is greater than angle 1. So that's it. We have completed the first part. Because we have angle 3 greater than angle 1, the side opposite to the angles. So let's refer to the side opposite to the angles. The side opposite to angle 3 is AB and the side opposite to angle 1 is BD. That's it. So AB is greater than BD, hence it is proved. Do you understand? So that is how we prove AB greater than BD. So similarly, we need to take this triangle. Okay, we need to have this triangle. Take this triangle for proving AC greater than CD. That you can try it on your own. In a similar way, take the exterior angle and compare the angles between them. See, take this exterior angle and compare these two angles. See, 1 and this. Since 1 is equal to 2, it has to be greater than 1 or 2. So hence we can prove that AC greater than CD. That you can try it on your own. Similar to this part, you can try AC greater than CD, right? Now the next thing is, show that in a right triangle, hypotenuse is the longer side. So this we have already done. So let us revise it once again. The concept we have already done. show that in a right triangle, hypotenuse is the longer side. So we know that the angle opposite, that is the side opposite to the greater angle is always the longest side. We have proved already, right? So that is what we are going to do now in a right triangle. They have given you it is a right triangle. So what happens according to angle sum property in a triangle? We have, what do we have? According to angle sum property, all the angles added together will give you 180 degrees, right? So angle A plus angle B plus angle C is equal to 180 degrees. Okay, so now it is given that angle B is 90 degrees is equal to 180. Therefore, angle A plus angle C is equal to 90 degrees. Isn't it? 180 minus 90 gives you 90. So, angle A plus angle C is equal to 90 degrees, which means one is a complement to another. That is, both are acute angles. Okay, because it is equal to 90 degrees, so it has to be less than 90 degrees. So, angle A and angle C. See, angle A and angle C both has to be acute, isn't it? Because one is 90 degrees, so both has to be acute. Therefore, angle A is less than angle B. See, angle A is less than angle B and angle C is also less than angle B. Therefore, the side opposite to 90 degrees, the side opposite to angle B, which is 90 degrees, the side opposite to the right angle has to be the longest. So, what is the side opposite to the right angle called? It is the hypotenuse, isn't it? So, this is the hypotenuse, and hypotenuse is the longest side in any right angle triangle. Do you understand? So, that is how we conclude. Just see the angles and these sides opposite to it. So, we'll be able to find a inequality relation with that. Okay, so just check it out and we'll move on to the next problem. Now, welcome back to the session, and we are going to see the last problem in this chapter, triangles, and this is regarding inequality relation in triangles. Right? So, the problem states PQRS is a quadrilateral four-sided figure in which the diagonals PR and QS intersect at O. So, we know a quadrilateral is a four-sided figure whose sides are not related to each other, that is, they are not equal or something. We have just a quadrilateral, and PQRS is a quadrilateral, and we have diagonals, that is opposite vertex connected. Vertices connected, that is PR and QS are two diagonals which intersect at O. Now we are given with two conditions which we need to prove. Okay, so now since it's a quadrilateral, we can divide them into triangles. We know that, isn't it? So we can spot triangles in it, and let us try to solve the problem, that is, prove the inequality given. So first we need to what we need to prove, PQ plus QR plus RS plus SP is greater than PR plus QS. That is, the sum of all sides PQ plus QR plus RS plus SP is greater than the sum of PR and QS, the sum of its diagonals. Okay, so let us try proving it. So first we take PR, the first diagonal, that is the PR, and the triangle associated with that diagonal. See, PR is the diagonal, so the triangle associated with that diagonal is triangle PQR and triangle PSR. Right? Okay, so we take those two triangles. In triangle PQR and triangle PSR. So, for our convenience, taken like this. So now we know we have already we have already done an inequality relation regarding triangles, that is, the sum of any two sides of the triangle is greater than the third side, right? We have proved that too. So now using that inequality relation, we are going to prove this. So now in triangle PQR, so let us take the sum of any two sides, that is PQ plus QR, will always be greater than the third side, that is PR. So let us take the sum, that is PQ plus QR is greater than PR. So this is for the triangle PQR. Next, for the triangle PSR, we have, what do we have? The sum of any two sides, that is PS plus RS, okay, that is greater than PR. So according to the names we have been given in the question, I rewrite it as SP plus RS. PS or SP both are the same. So SP plus RS is always greater than PR because sum of any two sides of the triangle will always be greater than the third side. So this is regarding the diagonal PR. Now we'll move on to the diagonal QS. So what happens in triangle? So QS, the triangle associated with QS, PQS and QRS, right? PQS and QRS. PQS and triangle QRS. So now for these two, I am writing relations. See, for what is this thing we have to make for QS, right? For QS, PQ plus SP is greater than QS. Okay, next QR plus RS greater than QS. Do you understand now? So let us check it out. So for the triangle, for the diagonal PR, we have PQ plus QR greater than PR. So this is the triangle PQR. Sum of two sides will be greater than the third side. So PQ plus QR will be greater than PR, and PS, that is SP plus RS, is greater than PR. Next, with respect to QS, we have the triangle here PQS and QRS. Now with respect to this triangle, PQ plus SP will be greater than QS. Likewise, QR plus RS will be greater than QS. Okay, so now we have four relations and let us sum it up. Let us add all together. See, we are going to add all the four relations because we need to have PR plus QS in the right side and all the other sum of all the sides on the left side. Okay, so let us add all the left sides and all the right side. Now in the left side, see, we have PQ and one PQ, so two PQ are there, and QR, so two Q are there, SP, SP2 SP, RS and RS 2 RS. So everything we have 2 times. So I will write it as 2 times PQ plus QR plus RS plus SP. So this is my left side. Now to the right side we have PR, PR 2 PR, QS and QS 2 QS. So we have, this is greater than 2 times PR plus QS. Do you understand now? So we have the same relation because we add all the left side and all the right side together. So the relation, inequality relation remains the same. So 2 times PQ plus QR plus RS plus SP is greater than 2 times PR plus QS. So 2 gets cancelled. Now we have PQ plus QR plus RS plus SP is greater than PR plus QS. So what does it mean? We have proved the first condition, that is the sum of all sides PQ plus QR plus RS plus SP is greater than PR plus QS, sum of the diagonals. Now do you understand how we have approached the problem? Keeping in mind the property we have studied with the triangle, that is sum of any two sides of a triangle will be greater than the third side. Right? So we have used that property, that inequality relation, to solve the first condition. So the next thing also is similar to this, the next condition. So just take a note of it. We'll move on to the next condition. Okay. So just keep in mind all the inequality relations while solving these kind of problems. So now we move on to the next condition, which states that, now see, this is something different from the first one. We have all the sides added up and it is greater than the sum of diagonals in the first one. The next thing is we are adding all the sides. The sum of all sides is less than when it is 2 times the sum of diagonals. So how do we prove? The first condition is greater than just the sum of diagonals. In the second condition, it is less than twice the sum of diagonals. So how do we prove? So for that, what do we do is, see we have an intersection point O here, right? So we can take triangles, we can spot triangles regarding this point, that is POQ, QOR, ROS and POS. So we can also spot triangles from this quadrilateral like that with reference to the intersection point, right? Because why do we do that? Because OP, that is PO plus OR gives you PR, the diagonal, right? Next, OS plus OQ gives you QS, the whole diagonal. So what we can do is we can split this QS and PR into OS, OQ, OP and OR. We have 4 triangles here, get the relations, and when we add we can have the full triangle like OS plus OQ is QS and OP plus OR gives you PR. So we can also get the diagonals from that way. So we'll take triangles with respect to O. That is, the first triangle is in triangle POQ. We apply the same inequality relation. The sum of any 2 sides will be greater than the third side. That is, OP plus OQ is equal to, is greater than PQ. Sorry, that is OP plus OQ is greater than PQ, which is regarding a triangle POQ. Next, in triangle QOR, what do we have? OQ plus OR is greater than QR, right? Am I right? Yes. In next thing, in triangle ROS, in triangle ROS, what do we have? We have OR plus OS is always greater than RS. Next, we have triangle POS. What do we have? OP plus OS is greater than SP. See, now we have got all the sides PQ, QR, RS and SP. Like PQ, QR, RS and SP, we have got all the sides here. So just need to add the RHS and add the LHS to get the required statement. Okay, so now let's start adding it. So now you see you have OP, 1 OP and 2 OPs are there, OQ, OQ, 2 OQs are there, OR, OR, 2 ORs are there, and OS there are 2. But on the right side, if you see PQ plus QR plus RS plus SP, sum of all sides we have. So for this, I take 2 times OP plus OQ plus OR plus OS is greater than PQ plus QR, because greater sign is there, plus RS plus SP. Okay, so I've got this. Now what about this left side? See, what is OP plus OP plus OR is PR. See, OP plus OR, so that becomes PR. And what is OQ plus OS? That becomes QS. So the 2 diagonals, we have obtained the 2 diagonals, and that is greater than PQ plus QR plus RS plus SP. So we have got the required statement. The only thing is the reverse. See, we have got 2 PR plus QS is greater, isn't it? So this is less than. PQ plus QR plus RS SP is less than 2 times. I have written 2 times PR plus QS is greater than. So both are same. That is, PQ plus QR plus RS plus SP is less than 2 times PR plus QS. So both are same. So we have proved both the conditions with respect to this quadrilateral by dividing them into, by viewing them as triangles in it, right? So with the help of inequality relations in triangle, we have proved this sum. I hope you understood all the criteria and all the inequality relations in the triangle. So with this triangles chapter, I think you have got an overview of triangles. We have studied all the properties of triangles, like starting from the beginning. We have the angle sum property, the exterior angle and the medians, altitudes we have done with, and we also know what is an angle bisector, what is a median called, and what is an altitude, how it is constructed, and what are the criterion for congruency, what is congruency and what are the criterion, what are the CPCTs, that is corresponding parts of the congruent triangles. So all these things we have read about, and please do keep revising. Until then, it's bye from Anu. Let's meet in the next chapter. Thank you.